Good morning, everyone. This is John Pendleton, your trainer today, and we'll get started here probably in about 5 more minutes. Wait for a few more people to get signed in. So we'll be with you shortly. Thank you. Good morning, everyone. I want to ask real quick because I'm not seeing it on my screen here. If you can see my screen, there should be a WV on the picture, but it's not showing that it's sharing my screen. Jim Stranlin, could you raise your hand if you could see my screen? Okay. Okay, great. Thanks, Jim. I appreciate it. Just want to make sure we could all see my screen here. I'm not really sure what's up with the GoToWebinar this morning, but we should be okay. Before we get started, just real quick, if you do have a question, you can raise your hand. It's going to be just me today. I don't have a host. So if you've got a question, I should see them pop up. It may take me a minute or two to get to them, but I will get to your question. And this webinar today will probably be probably a little bit closer to maybe 2.5 hours at the most, just depending on questions and that kind of thing. But I won't keep you for the full 3 hours. I know it's a little bit long, but it kind of is what it is. It won't be too bad, I promise you that. So before we get started, again, my name is John Pendleton, and I'm obviously the trainer at Enertech. Let's see here. Hang on 1 second. Slide that over. This is our technical support department. So if you have any questions that you think of after we get done with this webinar, you can contact me or you can contact any of the guys in tech support, and they'll be able to give you, answer any of your questions as well. Or if you're on the, out in front of a WV unit, the variable speed water to water, we can definitely talk to one of these guys. Kip's a lot of times is our point guy. I used to be one of them, but I've just gotten more involved with the training. So Kip's kind of spearheaded this WV, but any of us can and will try to assist you. You can call tech support. Right now, tech support is getting pretty busy. It's that time of year, So if for some reason we do not answer the 664-5860 number, it's probably because we're all on the phone. So just leave a voicemail and we'll call you back within, I would say, an hour at the most. And don't just hang up and call back over and over. It tends to get a little hectic. So just give us a call. We also have, let me go back here real quick. We do also have an email address. So if you have pictures or maybe a warranty form or something like that you want to send in, you can definitely email it to this technical services at Enertech Geo, and that'll go to all of us. We all have access to that email, or you can email individually if you want to talk to someone. Basically, it's always going to be at enertechgeo.com, and then our email address would be, if, let's say you're trying to get a hold of Rob Shawless, it'd be rob.shawless@enertechgeo. Same thing with tom.einhorn. So those are our email addresses. We also have an after hours phone listed down there at the very bottom. That's not really published a whole lot of places. So if you need after hours help, so after 5:30 in the evening and before 7:30 in the morning, you can call that on call, and it'll be one of us will have that phone. We're not in the office or anything on the weekend, but I guess a couple of the guys work remote, so they're basically in the office, but you can certainly give us a call, on the weekend or after hours. We do have design services, and you may want to work with them when we're trying to figure out a WV. As we go through this, you'll see there's options and things we've got to choose, and we want to make sure we get the right unit and the right package to you for this WV. So we do have design services that can help you, and that's Angelique Wood and Jeremy von der Haar. You can call design services. Their phone numbers listed here along with their email address. And for some reason you don't write all this down, this webinar today will be recorded. And so you can, once we get all kind of done and wrapped up today, it will send you an email letting you know that the video is finished and you can go back and look at it. It will also be uploaded to our YouTube page. So you can go to YouTube, and it's Enertech University, and all of our webinars that we've done over this past 3 or 4 months with the COVID going on, all those webinars are on there, and you're more than welcome to watch any of them that you would like. So you can always go back and refresh if you need to. We do have a dealer secure website, enertechusa.com. There's a link on here for Enertech University, and then there's a link on Enertech University to our YouTube page. So you can check out any upcoming trainings. I know I've got a heat of extraction, heat of rejection training tomorrow, and then I'm going to kind of feel those guys out and see what they feel like on some trainings for after that. So keep checking up on the Enertech University website for any new webinars, or maybe even soon, maybe in-person trainings. We'll have to see about that. So If you don't have access to Enertech, you will have to request access so you can get to the secure site portion of it. And basically, you're just going to fill out, a standard registration and a password. And don't worry too much about us sending you junk email or selling you email address, because we're not going to do that. So every user needs their own login. So if you're a technician, go ahead and make your own registration. If you're the owner of if you're a dealer, feel free to do that as well. So in the vault on our secure website, you will find product literature. There is some archived literature in there as well. So it's nice to go in there and try to find maybe some specs or something for an older unit. And there's also going to be service bulletins from tech support. What's nice, if you do register, put your email in and all that, we'll also send you, if we've got any tech tips or tech bulletins that are coming out, any kind of recall or something, we will email you and let you know. We have an e-news blast once a month that'll let you know kind of what's going on at Enertech, and it's kind of like our little newspaper, and we'll send that electronically to you as well. You can file warranties online. There's some marketing stuff on there as well for photos, logos, things like that. And again, you can link to the training site and find out what trainings are available and when the next trainings are. This is the Geothermal University or Enertech University landing page. You can kind of see the upcoming trainings, and so you can go on there and you can register right online. Now, when we get to the WV, when you decide you're gonna quote a WV, we've got to fill this little WV selection form out. And you can call customer service or you can call tech support, and we'll definitely help you fill this out. If it's your first one or you're just not real sure about one of the options, you can definitely give us a call. But if you go to enertechusa.com/WV selection, it'll bring you to this, and it'll ask you the brand, the tonnage of the unit, water configurations, things like that, what kind of tank options, controls, because the WV isn't just the WV, the little cube. The WV is a package. Depending on what your options are, the package could change, and you'll see the package as we go today. You'll understand a little bit better on how to fill out this WV selection chart or form. But the WV selection form must be filled out before the unit is ordered. Basically, once you fill this out, it's going to spit out a model number of the unit, because again, it's a whole package. So depending on what you choose, the model number will change. So we've got to fill out the form, and it'll spit out the part number that you're going to need, basically. The WV is made to do heating, cooling, and if you get the tank, 100% of your domestic hot water needs. It's a variable speed compressor from 2 to 5 tons for the 060 and 2 to about 3.5 tons on the 040. We can get up to 135-degree output temperature on the load water. We are using an internal variable speed load pump that will maintain delta T, or temperature difference. And there's controls inside the unit that will control your source flow center as well. And the source flow center is going to be a variable speed flow center, and it's the Magna Geo with a variable speed pump. If you need a second pump on the variable speed flow center, the second pump will not be variable speed. It will be like the 3-speed fixed speed pump. It does have an internal electric immersion auxiliary heater. It's a 9-kilowatt heater that's staged, 4.5 kW and 4.5 kW. We have outdoor reset controls that the unit will come with the sensor for the outdoor sensor. So we'll use outdoor reset on this. It makes it run a lot more efficient. if for some reason something happens to the sensor, we can always run the unit at a fixed temperature, but we would normally use the outdoor reset. And we'll discuss, the curve and how to choose which curve you need for that outdoor reset a little bit later on. We have on-demand zone control with multiple set points. Basically what that means is you can have like a radiant floor that maybe has a 90-degree set point, and you can have a air handler that in the winter would need hotter water than 90 degrees to do any kind of heating. So the unit or the controls are smart enough to realize what the call is, whether it's a radiant call, whether it's a hot water call, or whether it's a fan coil call, and the set points are different temperatures. So we do have multiple set points on water temperatures on this unit. Obviously, we'll discuss it as we go along today. These are the AHRI ratings. We rate it basically on a fixed temperatures in heating and in cooling. And these are the efficiencies of the WV compared to, like, let's say the WT, which is probably our most popular water-to-water unit. And you can just see that the WV, especially when we're running in part load, which we're going to be doing a lot of the time, you're getting an EER of like 25 and almost a 4 COP. So we really see a lot more savings with the WV as long as it's installed properly. Here's just some more of the COPs and the heating. We're normally running from, maybe 1,600 RPMs up to somewhere around 6,000. It'll go up a little bit more than that, but that's kind of the range that we're in. So we're running probably the minimum of a 3 COP. And again, when we're running down those lower RPMs, we're up almost to a 4. So it's got some really good efficiencies in heating and in cooling. We're in between, probably 11 or a 12 EER on the low end when we're up near that 6,000 RPM. But when we're running in those middle ranges, we really get well above 20 and close to 25 or 26 when we're, around 1,800 CFM or RPM on the compressor. We have a few different water heaters. Actually, I think there might be one more that we're going to have as well. There's a 45 gallon tank, a 65 gallon, and I believe you can also possibly get 109. I'm working on a new variable speed unit that we're in the works, and I know that it's got 109. So I believe the 109 is available if you've got, maybe it's you've got maybe 10 or 12 people in the home or something, then we may have to go to that bigger tank. But normally the 45 or the 65 model would be the tank that we need. With the hot water capability, it's more of an on-demand water heater. You're not really storing water. So like a 45 gallon Turbo Max tank would equal a 97 gallon electric water heater and about a 65, 70 gallon gas water heater. So it may seem a little bit smaller, but it's not really storing water. It works more like an on-demand water heater. Some of the recommended applications for the WV unit, we can do high mass radiant floor. We can use HBX controls. We can use the Hydro Connect, and we'll get into that about halfway through the training. We'll start talking about a little bit of the controls. But we can do up to 20 total zones of radiant. We can do hydronic forced air zone using an air handler. Now you can do heating only or heating and cooling. That totally depends on you. A lot of people, it seems that they want to use they've got a lot of radiant, so they're using radiant for their heating side of things, and maybe the hydronic air handler for the handle any kind of cooling. Now, you can have multiple air handlers on this as well. But one thing I want to say is, if you get the 060 unit, the 060 is a 5-ton unit. So you cannot throw 2 5-ton air handlers on here and expect that WV to be able to handle when both of those are calling. So if you want multiple air handlers, you're not going to be able to go over the 5-ton mark with those air handlers. So if you have 2 air handlers, then you could have a 2-ton and a 3-ton air handler. But you don't want 2 5-ton air handlers put on a 1 5-ton unit, because once they both run together, they're not going to be enough chilled water or hot water if you're doing heating to be able to handle both of those. So make sure that we remember that it is a 5-ton unit and we can't go over 5 ton of capacity on that unit. We do have, again, optional 100% domestic water with the TurboMax tank. We are always revisiting our control strategies, and if somebody decides out in the field they've seen a better strategy, you let us know. We'll definitely look into it, dig into it, and we can definitely switch up the controls. We have already a little bit. So what we offer in the manual is what we recommend and what we support. If for some reason you've got a different control package that you want to use, you're more than welcome to do that. But we're in tech support, we may not be a whole lot of assistance when it comes to diagnosing that control system. We'll do our best, but we can't know every control package. So I don't think that you're totally constricted to what we offer, but know that if you put something else or you're trying a different application, that it may not work, or we may not be a whole lot of technical support help for you. We would like larger flow zones. We've got to have, the WV must see 5 GPM or it will lock it out. And the WV has numerous ways to check for flow. So we have a flow switch, we have flow sensors. So if the unit does not see 5 GPM, it'll lock the unit out. So if you have a real small zone, let's say you had a bathroom that was one zone all by itself. Well, you're not going to be able to really run 5 GPM through that small zone and be able to heat with it. So we've put we shipped the unit with a bypass valve that will allow, let's say the bathroom only needs 3 GPM. So the bathroom will get 3. The bypass valve will dump 2 GPM back to the unit, so the unit will get 5 GPM back to it and realize that it's got enough flow. In the future, when we get to the next revision, the bypass valve will already be installed from the factory. But right now, the bypass valve comes in a box. And if you've got a small zone, or to be honest with you, whether you got a small zone or not, I would put that bypass valve in. If it doesn't need it, it's not going to open and bypass anything. There is a little bit of kind of wasted energy, I guess, when you're running through that bypass, but we're not going to run through that bypass all the time. It's just when you've got one small zone that can't handle the 5 GPM is when we're going to have that issue. So we shouldn't have the issue on any air handler call because we're going to get more than 5 GPM flow through there. But on a small radiant zone, we may not be able to. So we want to make sure we get the bypass valve installed. We do have some GeoFlow design calculators if you need to figure out your radiant flow or your fan coil pressure drops for sizing pumps. GeoFlow will ask you to register there as well, but I've registered, and the only reason they ever email me anything is when they've updated one of their calculators. We work with GeoFlow quite a bit, and they have some really good calculators on their website. I use them all the time. They've got hydronic calculators, design calculators, and pressure drops, and how much loop you're going to need, and figuring out pump sizing and stuff. So definitely go check it out. It's geo-flow.com. and register for that and check out their pressure drop calculators. We recommend using the loop length software to calculate the loop length if you're using the WV with domestic hot water, because with the domestic hot water, you're going to have a little bit more runtime on your loop. And so you may want to add a little bit more loop to the unit. You're going to have a little bit more extended run times with the variable speed. And so again, we just suggest adding a little bit of extra loop. Standard sizing of the total load is applicable, but again, add a little bit more loop for domestic water. And if you've got any questions on that, give me a shout, and I'll give you a hand on figuring out how much more you think you need. And it's going to depend on how much hot water you're really going to be needing and how often it's going to be used, that kind of thing. But want to make sure we get a little bit of extra loop, maybe like an extra ton of loop so we can make sure we cover the hot water portion of it and the extended run times with the lower RPMs. Some of the features of the WV, you can see the WV over here to the right. It's a Copeland scroll compressor. It's got an inverter in there for the variable speed. There's 2 swept braze plate heat exchangers, one for the load and one for the source. With braze plates, there will be strainers with the unit that need to be installed. And also with the braze plates, no open loop. Braze plate manufacturers don't like the open loop water. So if you've got an open loop, you're gonna have to put a secondary heat exchanger in to separate that well water from the unit water. With the variable speed technology, we were using an electronic expansion valve. The thermal expansion valve would not respond quick enough to our demands, obviously. So that's why we're using an electronic expansion valve. So far, they've proven pretty reliable. They're not as apt to get restricted like a thermal expansion valve because it's powered open and powered closed. So no debris will really stick inside of there. I've seen one of the electronic heads fail one time. Other than that, I haven't seen them get restricted, that's for sure. And if you've been in the field or you've been around a normal, even just an air conditioner or a heat pump or a geothermal heat pump, you know that TXVs sometimes can be our nemesis and tend to get a little plugged up and crap in the system. So there's an internal immersion electric heater. And you don't have to use the heater if you don't want to. You can turn it off. You can put it in economy. There's different ways you can handle the backup electric. And we'll discuss that a little bit later when we dig into the actual components a little bit. There's an internal 3-way valve for switching from your domestic hot water to your radiant. It's a 3-way valve inside the unit. It has an onboard HMI, which the HMI, that's a human module interface. Basically, it's the touch screen on the front of the unit, and it'll tell you when there's a fault or tell you when there's a call. You can go in there and navigate the menus and change things. In this picture, it's kind of towards the right, that little blue screen there. It does have internal Grundfos load pump that is variable speed. And it's in the back top of the unit. Here's kind of a little CAD drawing of the WV. You can see the HMI screen up in the upper left corner there. Most of the electrical components are in the upper cabinet, and then all your refrigerant connections and compressor are all in the lower cabinet. There is if you look on the right, down in the refrigerant cabinet, you see a little green box down there and a little black box below it. That's actually like all your sensors and things go into that little green board, all your load and source thermistors. And then that's an XEV controller below that, which controls the expansion valve. Here's an actual picture of a unit. It's kind of stretched out a little bit fuzzy, but I just kind of wanted you to be able to see the HMI with the green light on there. It's got buttons on it. Probably in the next revision on this, it could possibly be a touchscreen, but right now it just has buttons on the bottom that you can navigate through the screen. Key components. We have the EV2, which is a variable frequency drive. It's the big green and white board there with all the capacitors on it, and that's what controls the compressor. The HMI is in the lower center of the screen there. It's got a pumps menu on there. Controllers, we've got the XEV controller, the iPro controller, the control different components. We have flow switches, and we also have flow sensors. We have pressure switches, obviously, pressure transducers. You can kind of see the little bronze or brass fittings there. Those are pressure transducers and pressure sensors. And we do have a low pressure switch and a high pressure switch as well. We also have a flow switch, which is like the paddle switch. And there's lots of thermistors in the unit for obvious reasons. So again, those are most of the main components there. We do have a terminal strip that is removable for your calls when they come in. And we'll discuss that terminal strip, but it's a little bit different than your normal thermostat connections. We still have a reversing valve for switching from heating to cooling. And again, we have the expansion valve right there with the little black head. That's your electronic expansion valve, which is controlled by this XEV box over here to the right. Down in the bottom of that XEV box, there's a little green terminal strip. Right by there, there's some lights, and they'll flash, and there's like an orange and a green light. When they flash, that means basically that it's opening and closing, and more than likely it's working properly. This is the scroll compressor with the inverter technology. Again, it's Copeland. We work really closely with Copeland on this, and we're actually the first true variable speed compressor that was used in a Geo heat pump. I know Water Furnace said theirs was variable speed, but it was more of a step compressor, and this is true variable speed. This is the electric immersion heater. Again, this is a two-stage heater. If something were to happen to the heater, it needs to be replaced. It does have unions on each side so that you could disconnect it pretty easily if you needed to. I haven't really heard of any issues with the electric immersion heaters at all. Just make sure you don't turn it on when there's no water in the system. I don't know how you really would, but so when you get the package, this is what you're going to order. You're going to have the unit, whatever tank you need, your control package, whether that's HBX, Hydro Connect, whatever controls you may want to use, and then also your flow center, your source flow center. So you're going to have your variable speed flow center. Depending on what size of the unit, it could be a single pump or it could be a 2-pump. But this is going to be the package. You're not just going to get the unit, you're going to get the whole package. Make sure when you get the unit that you check it for any kind of shipping damage. Open it up, look inside, make sure all the components are there, make sure there's not, the compressor hasn't fallen over to the side, or there's not a big dent in one of the panels. Make sure you've got the proper tank and the proper controls and a proper flow center. If you have any freight damage, we've only got about 5 days to be able to file that claim. Now, if you're a technician out in the field and it's never been opened and you get it out there and it's been in your shop for a month and maybe a door is dinged up or something, make sure to let us know. We'll get you taken care of and we'll figure out how we're going to either contact the freight company or just warranty it. But don't think, well, it's been outside of 5 days, we're not going to take care of you, because we definitely will. And so we want to make sure that you're taken care of. We'll figure out a way on the other end of how we're going to handle it. So just make sure to give us a call if there's freight damage. It's not that big of a deal. If you need a new door or something, we'll get you taken care of. Make sure you always keep it in the upright position, similar to like a refrigerator or anything else. We don't want that oil to drain out of the compressor and then have the compressor run with no oil in it. So make sure the unit is always in the upright position. You cannot stack the units. They're not to be stored outside. They're not to be installed outside. And due to the weight, I mean, you've got 2 braze plates, a compressor, a load pump. I mean, the unit's probably somewhere around 400 pounds. So a lot of dead weight, especially in the bottom of it. So make sure you're using proper hand trucks or have a couple guys or something to move the unit. It's not the lightest unit out there. So just be careful when you're moving it around. Make sure you've got the right unit. We only have 2. We have an 040 and an 060. So I would hope that we got you the right unit, but just make sure, inspect all the electrical connections. Sometimes things vibrate and become loose in shipment. And so make sure even the factory connections are tight, so we don't have a problem with any kind of overheating of the wiring and burning up of the connections. Take a quick look at the refrigerant piping and make sure that it's not touching anything. There's no rubs or kinks or anything like that. And if it was me and I had never installed this unit before, I would probably, if I had an opportunity, I would get the manual and at least look over it before I started digging into the install. There's, little few tricks and things that you might see in that manual on how to set it up that will really make your install go a lot smoother. So definitely take a look. If you don't have access to the actual physical manual, you can go online and you can get it there, or you can always call tech support and we can send you a PDF of the manual. It's not a big issue. Inside the unit, obviously there's the manual, and there are 2 number 40 mesh Y strainers. Those are not optional. Those need to be installed. That's why we sent them with it. And it's the braze plate manufacturer. They want those Y strainers in there to protect their braze plates. The passageways through the braze plate are so small that really any debris is going to get plugged up in there. And then if you don't get proper water flow, a braze plate does not handle being frozen very well. Now, it'll freeze the first time and you might get lucky. The second time, it's not going to happen like that. And then you're going to have water in the refrigerant circuit and the unit's going to be pretty much trashed out. So make sure we're protecting those braze plate heat exchangers as much as possible. The variable speed source flow center will come with the unit, and it will come with a 15-foot connector that plugs into the WV unit and plugs into the Molex connector on the flow center. So it's a real plug and play. Just plug it in and let the WV unit control it. The flow center hose kit will come with the unit. Obviously, there is an internal variable speed load side pump already installed in the unit. The outdoor air sensor will come with the unit. You will have to, obviously, we don't send, unlimited wire with that. So you'll have to use some thermostat wire to run to where you're going to mount it. The hot water tank will come with the unit if you ordered it with the tank, and will also come with the bypass valve. Again, at this time, it's not factory installed. In the future, we will be installing it at the factory. But you can also install it outside of the unit as well. And it'll come with the instructions on how to set it up. And we'll go through that a little bit here as well today too. Obviously, there's high voltage power from a couple different sources in this unit, especially if you're using the electric heat. So just remember that there could be a couple breakers that you need to turn off before you go throwing your hands up against that high voltage power. Nomenclature overview. So if you're not familiar with our model numbers, they're always going to start with the brand. So if you're a GeoComfort, Hydron, or Techco, you probably won't see the A, which is GeoExcel, but you'll see a G, a H, or a T. That's just the brand. The second digit is the type. This is a water-to-water unit. And the third is the stage. And this is, you may see S or T on a standard unit for a single stage or two stage. This one is a V for variable speed. Then you've got your unit capacity. So we have an 040 and an 060. The next is the revision. Right now we're on A. B will probably be, I don't know, probably next year sometime, I would imagine. The voltage code is, we only have it in 208, 230 single phase. The next is your hot water configuration. So it's either going to be a 9 with the indirect hot water tank or a 0 because you're not doing hot water. The next is your flow center option. So either it's going to be a 1 pump or a 2 pump flow center. And then again, if you've got a 9 in your hot water configuration, then your tank option will either be a 1 or a 2. If your hot water configuration is on a 0, your tank option is going to be a 0 as well. Then we've got your load heat exchanger and your source heat exchanger. There's only braze plate. That's all we've got. So that's going to be, both of those are going to be a B. And then the final is a standard stock, and that's more for internally. If we were to change something, we might change that to a different stock letter, but that's always, normally that's going to be SS on the WD. Oh, sorry about that. Serial numbers, just real quick on a serial number, it's pretty easy to know how old the unit is with the Enertech unit. Basically, the M is for where it was built. So we build our units in Mitchell, South Dakota, and then it's going to be the year and the month. So in the example, that would be 2017 in the 9th month. So September of 2017 is when that unit was built. The next is a number on the day of the month that it was made. I don't ever really worry about that number too much. I always just look at the 17 and the 09. So that pretty much tell you how old that unit is. Unit location. Make sure you're real careful about putting it in an unconditioned space. You could have frozen water lines, excessive heat. It could be humid in that area. Crawl spaces aren't really the best place for the unit. They'll rust out prematurely. Serviceability is always priority number one. I know if you ask installers, that's probably not the way that they feel, but as a service technician, you're going to have to work on that unit sooner or later. So with this unit, you're going to have to be able to get to the back, obviously the front, and it would be nice if you could get to at least one side of the unit. So throwing this into a small hall closet or something like that is not going to work. You're going to need a little bit more space. An insulated and isolated location is strongly recommended. This unit's actually very quiet unless the door is off. When the door's off, if you've ever ridden on like a regional jet and you have that kind of that whining of the engine, that's kind of how this sounds when you got the door off of it. It sounds like, you know, a plane getting ready to take off. With the door on, you really don't hear it that much. It's pretty quiet. But we'd really recommend insulated and isolated location. Dimensions, and it doesn't matter if it's the 040 or the 060, they're the exact same cabinet, but it's 37 inches tall and 25 inches wide, 25 inches deep. There is a case inlet fan that will require a 4-inch clearance, and that's to keep the electrical components clean and cool. There's a filter on there. We have a part number RF119. You don't necessarily have to use our filter. If you had some filter material or you know, maybe even like the more foamy type filter that you could wash, you can use that. Or you can, you know, cut some fiberglass filter and throw in there. But that'll probably need to be changed or at least looked at, you know, once a year. So if it gets too dirty, there is an alarm that'll tell you if the controls are getting too hot. If they are getting too hot, check that filter and check that fan and make sure that fan is running. We recommend, excuse me, we recommend 2-foot distance around the entire unit. You know, in a perfect world, that's what would happen. I understand if you can't, but as we look at this unit, you'll kind of see why we kind of need that. The unit also needs to be set on a pad. Do not use corner shims. If we only set the unit on shims or blocks or bricks, we don't support the whole base of the unit. We have, the compressor could vibrate somewhat, or the whole unit, and weaken the metal in the bottom of the cabinet, and then actually that compressor could fall through at some time. It weakens the metal over time with it bouncing there. So not that we have a big issue with vibration on the unit, but it could happen. So make sure you're putting it on, you know, I would not use the foam pads that we have. We have a new rubber pad that's maybe 1 inch thick. That's what I would recommend. The foam pads, there's so much weight in the bottom of this unit, and the compressor and one of the braze plates sit kind of on one side. If we put it on that foam pad, it tends to want to sag over time. And we've only found that out by putting a unit out there, and it happened to us. So, because it doesn't happen right off the bat. So the unit gets out a level a little bit, and it's just not a good look. So we do have a real thick rubber pad that we can use. Now you could also, I know you guys have seen probably like those waffle pads that you can buy and you can break off like a 2-inch square. You could use one of those waffle pads, but it'd have to be like a whole bunch of the little squares together in a big sheet. And you could use that. Those get a little bit expensive when you do that, but I'm not real sure of the cost on ours, the little 1-inch, but it's a good solid pad, and I highly recommend it when you're using the WV unit. You're gonna have to be able to take off the top of the unit if there's a problem with the 3-way valve or the load pump. So we're gonna have a little bit of clearance above the unit as well. At least enough to get your hands and your head down in there, or, you know, over there, so you can work on it. So you could rack, if you had numerous WVs, you could rack the units on top. You just can't stack them directly one on top of the other. And if you do have racking, give yourself some room so you can work from the top of the unit. This is looking down from the top of the unit, and you can see that little red cylinder with the black box is your load pump. And then the orange rectangle next to it, that's your 3-way valve. If you ever have a problem with a 3-way valve, let us know what color it is, because we're starting to change to a different valve. And right now, there's no defined serial number where that switched over. We're working on that, trying to figure that out. But if you call in the tech support, let us know if you have an orange valve or a red valve. If you don't remember, don't really worry about too much, but the orange valve was the original valve and we've gone to a newer one. I don't know why. I don't know if it's due to availability or what. I don't really think it changes the operation of the unit any, but it's nice to know when you're in tech service which valve you have. So. General installation practices is pretty much the same as all the rest of our geothermal units. You know, you're still going to have to flush and fill the loop field. You're going to have to flush and fill the load side, the hydronic side of things. The electrical wiring isn't really a whole lot different. There's terminal blocks that you've got to wire into. You still got to wire it into, you know, your circuit breakers. The setting of the unit and the piping of the unit's not a whole lot different. You still need to insulate the load and source piping, and hose kit installation is, again, still 10-foot max distance there and back. So you got to keep that flow center still pretty close to the unit. Excuse me. This is the source and load piping on the unit. This is the back of the unit. So that's what's one thing that's a lot different than any of our other variable speed units or our water-to-water units, or really any of our geothermal units, is that the water connections are on the back of the unit. They're all 00 ring fitting, and you know they kind of run on a diagonal. So you have your hot water out, your load water out, your load water in, which is your common. So whether it's for the hot water or the load, and then you have your source out and your source in. Don't forget to put strainers on your source in and your load in lines. Again, they come with the unit for a reason, so make sure we're installing those in the water lines. There's a few different control strategies that we can use on this unit. On demand, so basically the heat pump only operates if one of the zones or the domestic hot water tank is calling. So on demand, you don't necessarily have to have the tank, or, you know, there's no real buffer tank. There's no storage water. Now, you can add a buffer tank if you can't get 5 GPM of flow and you want to separate the zones from the unit. But at that point, you're kind of, you're not really taking advantage of the variable speed. So you might as well go with a fixed speed unit. You know, that would be, you know, the buffer tank, the dump zone, primary, secondary loop. Those are all things you can do, but we're not going to cover those in this training. If that's something you want to do with a buffer tank or a dump zone, give us a call and we'll work with you one-on-one on that. Again, we got to remember that 5 GPM, that unit has to see 5 GPM. Recommended configuration, high flow zones, so large zones. Yeah, in a perfect world, we'd have large zones, you know, that can handle 5 GPM each, but it doesn't always work like that. It is the most efficient way to do it, and it simplifies the installation, but again, it does require large zones that can handle the 5 GPM. As long as you've got that bypass installed, small zones are okay. It also protects from pump deadhead, because you can, if for some reason that pump comes on and your zone valve is stuck closed, that it'll just dump that flow through your bypass and it's not gonna affect your pump. It's a little bit more complicated because you have to set up the bypass valve correctly, but it's really not that big of a deal. It's pretty easy to set up, I think. Especially after you've done it one time, you'll be fine with it. So it does complicate it a little bit more because there's a little bit more piping, but it's not really that much more difficult. You do, again, lose a little bit of efficiency because you're just bypassing water that you've just heated right back to the unit. So you are losing a little bit, and it can cause the unit to overshoot temperatures and short cycle the compressor. The one thing good about the WV is when it does short cycle, it's not like it shuts down the whole system. It only shuts down the compressor. The pump keeps running. When those temperatures come back within range, then it turns the compressor back on. So you don't have your 5-minute and a short cycle or anything like that you got to worry about. It makes it a lot better. I mean, again, you will have a little bit of short cycling, but you probably won't even notice it. This is a typical system diagram with a hot water tank, a hydronic air handler, and some manifolds. Make sure we're still installing PT ports and source Y strainer and load Y strainers. But always install PT ports. Yes, we have thermistors and sensors that tell us, but those can go bad. And so we always want to refer back to our normal practices with a fixed speed unit of installing PT ports, and so we can check pressure drops and water temperatures, things like that. Again, this is the internal load pump. It's basically the same pump as your source flow center. It just looks a little bit different because it is the Magna 32140 pump. The volute and box is already insulated in the cabinet, and it's basically controlled on delta T, which is built into the controller on the unit itself. It's suitable for the majority of the installations. If for some reason you don't have enough pump, then you can add an external pump to the system outside of the unit. I haven't really seen that. Maybe once I've seen that, but normally the load pump is able to handle the pumping. So no real issues on that. Again, if you don't have enough pump, we'll throw one on externally. This is just basically the feet ahead and the GPM on the pumps. I'm not really going to get into that too much today. This is the newer version of that 32140. You can see it's a little bit smaller, but this is what we will be going to. They're not in the unit yet, I don't believe, but sooner or later, this is what we will have. It does have a little screw there where you can actually bleed the shaft of the pump itself. Again, this is the internal three-way valve, and it's basically deciding whether you're in hot water, domestic hot water heating, or you're in heating and cooling for your hydronic side of things. Again, it's located in the back near the load pump and the load connections in the back of the unit. Zone valves. I would recommend using this Taco Century zone valve. It's got an end switch on it, so it'll allow the thermostat to call, send it through the zone control, open the zone valve, allow the water to flow when the unit gets its call. That way we know we've got the end switch is open and we know we've got flow. There's other zone valves you can use. You're more than welcome to use whatever you want, whatever you feel comfortable with. I just really like this Taco Century zone valve. You can just replace the head if the head fails. And to be honest, these are pretty reliable. We don't have a whole lot of problem with them. It's got a low CV rating on it. And again, they're super reliable. I would recommend using the Century valve. But again, that's totally up to you. Manifolds, you can make your own, or you can get the in-floor manifolds for your radiant. These are kind of nice. You can set your flow. You can shut them off if you need to, and they've got an air bleed on there as well. You can get them in 2, 3, 4, 5 circuits. Make sure you always remember that you may have to use your bypass. And just some of the recommendations that we recommend: that the first zone should be a minimum of 1.25 to 1.5 inch piping going to it. And but again, you can make your own manifolds, or you can buy them from us or in floor, where they look nice and pretty there. It's totally up to you. Air handlers. This is our MPH air handler, H standing for hydronic. And I would recommend, I think it's 3/4 inch copper pipe that sticks out of the unit, but I would recommend 1 inch to 1.25 inch copper pipe, and use the zone valve as part of the zone control. Make sure again that if you have numerous air handlers, that the tonnage of the air handlers is not larger than the size of the unit. So don't use 2 5-ton air handlers hoping that they won't run at the same time. If you need 2 air handlers, make sure it doesn't total more than 5 tons. If you've got the 060, if you got the 040, obviously we don't want to go over that 3.5 ton load on it. It's something I really didn't think about too much when we first started training on this unit, that we do have to make sure we stay within the capacity of the WV unit. If you need some specs on the air handlers and their capacities, you'll have to look in the air handler manual. If you need an air handler manual, I can definitely send you it, but it'll give the different capacities at different water temperatures, so you can size the air handler properly. Again, the air handler has 3/4 copper stubbed out, but again, I recommend running at least 1 inch, if not 1.25 inches, up to the unit. Bypass valve, we kind of talked about the bypass valve, and it basically works on pressure difference. So you can kind of see in this picture at the very top, it's like 7.5 PSI. And once it sees that pressure, that much pressure, then it allows bypass and flow some water through there. You can basically adjust it when you start up the unit. Once you have a higher flow rate to the rest of your zones, it will automatically close back off and not bypass if it doesn't need to. Now, again, it helps prevent deadheading, and it ensures minimum flow for small zones. Normally, I've seen this valve, it's basically tightened all the way down to near that 7.5 PSI mark. Seems like it's always between 6 and 7.5, somewhere right in there, from my experience in the field. If you look at the bypass valve here, at that little nut on the right side of it, normally there's a little white neoprene gasket in there. So make sure it comes in the box, but it's usually stuck in that little nut there, but it easily falls out. And I've seen guys hook that up and then it leak because the washer is falling out. So make sure that washer is in that nut before you thread it on. To adjust it, you're going to adjust it during startup. When you're into the startup wizard, because you're going to be running your pumps and not anything else. So you can kind of see on the screen what your flow is. You can dial that in and kind of see how it affects the flow. You can set it about midway, which is about 4.5 PSI. And always start, it's going to ask you what your pump minimum should be. Your pump minimum, don't set it like it's 0. You'll probably see, the way we set that pump minimum is the minimum flow that you want to see that unit. So if you set your pump minimum, it comes from the factory, I believe, at 60%. If you were to leave it at that and run the pumps, and let's say that you're getting 4 GPM of flow at 60%, you need to raise that pump minimum until you see 5 GPM. Now, and if you need to lower that, that's fine too. We just need to find out where your 5 GPM is at and what percentage that is. So you have to play around with it a little bit. I've always seen it somewhere between 45 and 60%. So it'll almost always be between 45 and 60 to get your 5 GPM. Now, when we say the unit has to see 5 GPM, I personally would like to see, when you set up your minimum, to be about 5.5 GPM to give it a little bit of wiggle room. So that way it doesn't float there on the edge and you get a little micro bubbles or something, and then the pump, then the unit shuts down on flow. So you may want to, bump it up to maybe a 5.5 GPM minimum, and that could be 40% pump minimum. We just don't want whatever the pump minimum speed is to drop below that 5 GPM. Once you set that pump minimum, go ahead and smallest valve or smallest zone and see what the flow is. If you've got enough flow through there, then you won't have to adjust your bypass. If you're still not getting enough flow back to the unit, then you'll have to adjust the bypass valve to provide a minimum of your 5 GPM. And you can turn it counterclockwise until you get at least a 5 GPM back to the unit. You may need to then go back and readjust your minimum pump speed. It sounds more difficult than it really is. When you're standing in front of the unit and you start to do this, you kind of see what's going on. It's not really that difficult. And again, if it's your first one or anything, you can feel free to give us a call. We'll definitely help you through it, or you can pull up this video and watch it again. It's really not as difficult as it seems. It's just kind of wordy, I guess. Again, this is the indicator. It's kind of the same wording, but there are 3/4 inch MPT fittings on the valve itself, and it will have a little nameplate, and then you can kind of see the percentages or the pressure that it takes to open that valve. The hot water tank, it's an indirect tank, so it's kind of like an instant hot water. So basically, you're normally, when you see a water heater, it's just got your domestic hot water all in that tank. Well, that's what you would think about this too, but that's really not the way it works. The domestic water enters the bottom of the tank. There's a copper coil in that tank. The domestic water runs through the middle of that coil. The WV bulk load water is on the outside of that. And so the domestic hot water tubing is immersed into the WV load water. So as it runs through the copper, it picks up heat from the bulk load water that's transferred through the copper and then sends it out to the domestic. So to your shower, to your faucet, whatever that may be. So the WV maintains that bulk load water, and then your domestic runs through the middle and picks up that heat. Again, we have a 45 or a 65 gallon tank. The WV load water enters the top of the tank and goes out the bottom, and the domestic water enters the bottom and comes out the top. Basically, it's like the reverse return. So the colder water from the domestic is in contact with the colder water from the WV, and vice versa. Heat transfer works a lot better that way. But know that the load water or the domestic water is in its own little separate coil inside of this unit. And then the WV bulk water is on the outside of it. This is just some sizing of the tank, how fast it will recover. So this is all in the WV manual. So if you're trying to figure out, tank size, or you want to know what it's comparable to, you can just look in the WV, and we've kind of laid it out here for you, what the recovery rate is, what the compatible water heater is, and also the dimensions of the water heater itself. The domestic water connection is an 1.5 inch sweat male copper fitting. Heat pump connection on the 45 gallon tank is an 1.25 inch MPT, and the 65 is an 1.5 inch MPT fitting. There is a pressure relief valve, and I'd recommend that you run it to a drain. because when you flush, if you get over 35 PSI or whatever that pressure relief valve is, you'll pop it open and it'll dump water out. We found, I remember when we installed the very first one of these, we, not thinking about it, went to go flush, and of course got it over to 35, and we didn't have the relief plumbed, and of course we're standing right there in a small little room, and we got a little bit wet. So sometimes the easiest way to learn is to make a mistake. So we learned that, hey, yeah, we probably want to pipe that relief in case it does, in case we do get pressure a little bit too high. We don't want to try to pop that valve, but it is possible that it could happen. So I'd pipe it near or to a drain before flushing. This is basically a tank diagram in with the unit, and the WV will decide whether it's going to send the hot water to the hot water tank, or it's going to come back, to your manifolds or your hydronic air handler. The load, obviously, you have one load out and a return load, but it's going to handle the hot water or the hydronic heating. So it's got a common return on it. Source side water connections on the flow center on a closed loop only, because we don't want to, if you've got an open loop, we've got other things we got to do, but it's on a pressurized or non-pressurized, they're all double O-ring anymore, which is nice. And again, it will come with your hose kit, which is a 1-inch, 10-foot max per unit connection. So 5 foot to the flow center and 5 foot back to the unit. Again, if you have a open loop, then you're going to have an external heat exchanger record that water from getting to the WV unit. If you have an open loop and that's the way you want to go, you'll have to give us a call in tech support or design, and we'll get you a part number for an external heat exchanger. Flow center diagram, it's really not a whole lot different than any of our other units. Again, double O-ring fitting, and it's going to go to source in, source out on the back side of the unit. Just like that. What's nice about even the non-pressurized flow centers anymore and the pressurized is that they have three-way valves that can isolate the unit, and you can hook in your flush cart and be able to flush right there at the source flow center. When you're flushing, make sure you flush in the direction of the flow for the Y strainer. That way the Y strainer will catch anything as well, and you're not just going to blow it back into the system. So always go with the direction of flow on the source and the load for that matter. We would highly recommend that when you do flush that you use filter socks. There's two different filter socks that we have available. We've got a 100 micron, which is the bag on the right. It's kind of dirty. And the 1 micron, which is the bag on the left. Both bags are reusable and washable. The one on the right is real brown because the system had a lot of rust in it. And we've used it quite a few times, and it gets stained over time, but it doesn't hurt the filter ability. If for some reason you don't have a filter sock or you've lost it or something like that, and you want to at least try to get some of the bigger debris out, you can use like a pantyhose. That's about 100 microns. I know a lot of guys in the past, before they even had filter socks, would use a pantyhose. And you can just basically drape it over, and it just collects any bigger debris that's in the system. But highly, highly, highly recommended that we use filter socks. Load flushing, we got to make sure that we flush the load side. In my opinion, if you have air handlers and radiant, try to put some ball valves in where you can isolate those circuits and shut them off so you can just flush the air handler or just flush the radiant. It'll make things go a lot quicker and you get a lot more air out. I found that with the hydronic air handlers, those have a really hard time of getting all the air out. So if you can isolate it and just flush through the air handler, it'll probably get a lot more of the micro bubbles out. Once you get the unit running and you see a lot of fluctuation in your flow, that's probably micro bubbles working their way back to the pump. So we've got to make sure that we're flushing and flushing well, the load side as well. We've got to have more than city water pressure. So I would isolate the heat pump first before flushing, and do not flush the system through the heat pump, because we want to make sure that when we do flush through the heat pump, that we go with the direction of flow. Make sure the system is clean and filled with good quality water. Always test your water before you put it into the system. Even if it's an existing loop field, I would check that water. If it needs to be treated with Fernox, then treat it. You know, it's a peace of mind if nothing else. It seems like as we go along more and more, water quality just gets worse and worse. So we're always fighting bad water. If you start losing pumps a lot on a system, take the pump apart and look at it. It'll tell you if you've got bad water quality almost every time. So, if you start seeing, you're losing a lot of pumps or something like that, take a look. Don't just replace the pump and move on, because you're not really fixing the problem. Take a look at that water, make sure that it's good, clean, quality water. When you are flushing, you may want to isolate or even plug the relief valve. Now, I'm not saying you got to leave it that way, because you could purge water out of it. The only other way, if you don't want to plug it, is just be careful that you don't get your pressure above the 30 or 35 PSI, whatever that may be, so you don't open up that relief. The last step that we would do when we're flushing is to go into the startup wizard, and it's going to prompt you to energize the hot water circuit so you can flush that circuit as well. Basically, you're going to flush the tank, the bulk portion of the tank, and that small line. It won't take real long to do that, but we've got to go into the setup wizard to be able to do that. And that's the first thing it's going to ask you, is flushing complete, because you're going to energize the three-way valve first so you can flush that circuit. Make sure you leave your flush cart down there and flip on the unit and switch over that valve. Now, if you just want to flush it and then you're not ready to start the unit up, that's fine. You can turn it on and it'll immediately take you to that to energize that circuit or that valve. You can flush it, you can shut everything down, turn off the unit, and then when you're ready to do the startup wizard for initial commissioning, you can go right back into the startup wizard when you initiate power again. Load side antifreeze. Anytime you're cooling with chilled water, we require antifreeze in the load side of the heat pump. So anytime you're doing chilled water, put it on the load side. I've just seen these brace plates freeze, and I just don't want that to happen. So just not a good situation when it freezes up. If you have any heating zones that could potentially freeze, either isolate that zone and add antifreeze just in that zone, maybe put a separate plate and just antifreeze on that zone, or install antifreeze in the entire load system. That's totally up to you how you want to handle it. But with these heat exchangers being brace plates, they just don't handle the freezing very well. So make sure we're being real careful with the freezing potential. I would install boiler drains on the load side for flushing. And again, you may also want to put some ball valves in to isolate the tank for the domestic, and flush the whole load side by itself, and then the hot water tank by itself. That way you don't have to worry about it for the most part when you're doing your radiants or your air handlers. But when you get into domestic, then you can be a little bit more careful and watch that pressure relief. But again, install boiler drains on the load in and out for your flushing. You could also put in flush blocks if that's what you want to do with the double O-ring. However you want to do it, just know that we have to flush the load side, so we have to make some way to get into that load side for flushing. Electrical connections, you have connections on the left or the right of the unit. So the high voltage connections are on the lower portion, and the low voltage signal wiring is on the upper portion. Again, you can come in on the left or the right side of the unit. There's knockouts on both sides. Again, this is the control block or control box showing some of the controllers, and the low voltage field wiring is a removable terminal strip, that green bar. Then you've got your pump blocks, your high voltage wiring for your electric immersion heater and the unit itself. You've got some fuses that protect the pumps. We have our digital controller for handling the compressor. Now, when you get the unit itself, like the pump block, it's going to have a sticker that tells you that that's your pump block. It's going to have a sticker that tells you where your immersion heater power goes and where your main power for the compressor goes. So we kind of laid it out for you. The relays down the bottom are your immersion heater relays, and there's stickers on there as well to tell you kind of what's going on, so you don't have to remember where everything is. We did add some stickers. This is a 230 volt single phase unit only. You will have to have two circuits, a 50 amp primary for the Geo and a 50 amp for the electric heat. We do recommend this compressor Defender over here to the right, and we've just started, I believe, carrying it. I'm not sure pricing or anything like that. It's not required, but it's highly recommended. It's a CD1-024R. If you've got a unit out there now already in the field and you'd like to get one and put it on, there's the part number, and you can talk to customer service, or to be honest, you could probably go online and find one just as well. But I would recommend it. You can use it on basically any unit out there, but it's going to monitor your voltage, and if there's a problem, it's going to shut the unit down. Basically helps save a lot of these controls and things that are inside the unit. Again, high voltage connections, we've got a terminal block. Make sure that the factory connections are tight when you're already in there, and know that there's two different power sources for the unit itself. Variable speed flow center is controlled by the WV. Again, there's the internal pump block for the high voltage power and a Molex connector for the low voltage, so it just plugs right in. The high voltage, the variable speed pumps will always have high voltage power, and then the low voltage signal wire controls it. And they're controlled on delta T, and the default is 5-degree temperature difference. Again, there's the low voltage connection, that little Molex connector, and the high voltage is inside that box there. You have to run the wire from the flow center to the unit itself. There is the pump block for the variable speed, and then if you have a 2-pump flow center with the fixed speed, it's got its own separate pump block. So if you hook it into the variable speed pump block by accident, then the fixed speed pump will run all the time. That's not really what we want. It's not the end of the world if you do that, but you'll find out pretty quickly and you go, oh, I think I've got those switched around. So again, there are stickers on the unit or inside the panel, so it'll tell you which one is your fixed speed and which one's your variable speed. Again, both pump blocks are protected by 7-amp resettable fuses. Although if they trip too many times, they're just like plastic and then they won't reset. So if you keep blowing a fuse on those, there's probably an issue. But there is the pump signal connector. It's inside the lower control box. Again, it just plugs right in and it comes with a 15-foot wire. So if you've got to go up to the ceiling and over and then back down to your flow center, we gave you plenty of wire to be able to do that. For some reason, you have to go even farther than that. You could cut into it and add more wire to it. It really wouldn't be an issue. Let's go ahead and take a quick break, maybe like 5 minutes, and then we'll get back into it. Probably about another hour or so left in the training. We'll get into a little bit more of the controls and things like that. So I'll see you here in 9:30, so about 9:35, just enough time for us to go to the bathroom and grab a cup of coffee. Thanks, guys. Okay, let's go ahead and get started back. This is the pump controller. It'll basically, there's all these buttons. They're kind of hard to see in this picture here, but there's buttons underneath all where it says main, comp. You can see the pump is kind of highlighted there. And so if you want to go into that menu, you can press that button and it'll bring up your load and your source pumps. So it'll show your percentages of the pump speed. If you've got flow, it'll say yes. If it's not seeing flow, it'll obviously say no. It'll tell you what the GPM you're seeing is and what the entering and leaving water temperature is. And we'll get a little bit deeper into this here in just a little bit. We already kind of discussed the auxiliary heater, and it does require a separate 50 amp circuit. And you can also go in there and turn it off if you really wanted to. Again, electric immersion heater has its own separate power, and there will be a sticker on there to let you know that that's the immersion heater high power connector. The thermostat calls, I guess if that's what you want to call them, come into this green terminal strip. And it'll say Y1, Y1C, Y2, Y2C, OC, HW, HWC, RC, OAT, and OAT. So Y1 and Y1, let me back up. All these contacts are dry contacts. So if you want to see if the unit is working and it's not coming on, and you're not sure if it's the control side of things or the unit, if you were to remove your connectors from all the controls that come into the unit at this green terminal strip, and you were to jumper, just take a little jumper wire and jumper from Y1 to Y1C to dry contact, and that completes the circuit. So it's not really voltage that's required. If you were to jumper Y1 and Y1C, your compressor should start running, your pumps should come up to speed, and it goes into a radiant heat call. So it's an easy way to really tell if you've got a control issue outside the box or if you've got an issue inside the Geo itself. A quick diagnostic tool to kind of separate and see where your problem lies. Again, Y1 and Y1C would be your radiant heat call. Your Y2 and your Y2C is your air handler call. O and OC is an air handler cooling call. HW and HWC would be the domestic hot water call, or your call coming from the aquastat that's on the Turbo Max tank. And then OAT, those are for your outdoor air temperature sensor, your thermistors. And it doesn't matter which wire goes where. From that OAT, just go to both of those connectors there. Wiring diagram selection chart. This is in all the manuals. It's a quick way to look and know which wiring diagram you need to follow when you're wiring this unit in, and also what it's compatible with and how to, what you really need. So it kind of helps as well when you're designing the system. You know, if you've got, you know, a heating only and you want to use HBX, there's certain parameters you're gonna have to follow. You know, this HBX zone 550 can handle up to 4 radiant zones and must use the THM 300 or 500 thermostats. I'm not gonna dig real deep into the controls portion of it because there's so many different control strategies, and there's so many different ways to install the unit. So I'm not going to cover all of these today. I just want you to see where they're located, and you can look at those. And then for more specific questioning on it or things like that, we can work a little bit more on a one-on-one basis on how to wire this up and make sure you've got the proper controls. Personally, from my experience in the field and working with technicians on the phone, The HVX is a little bit harder to grasp and wire in and kind of understand. So I would recommend using the Hydro Connect controls, and that's like the HC3, HC4, HC5. That Hydro Connect is more of a plug and play, a zone type system. It's a lot more easier to set up. You can order it with just one air handler, or if you have multiple air handlers, we can get an expansion panel for it as well. And again, it just, if you don't have a lot of control experience, it's going to be a lot simpler with the Hydro Connect controls than the HBX. Now, if you're very familiar with HBX, go right ahead. But if this is your first time using HBX, I wouldn't recommend it. I would recommend the Hydro Connect controls. Just my opinion. I think that there's quite a few of us at Enertech that would agree with me on that, just because we've had quite a few issues with the zone, with the HBX. Don't let that scare you, because if you're very comfortable with them or have used them in the past, they are good. I mean, they can do a whole lot. But for a newer controls guy, they're not the most intuitive controls. So just give us a call if you got any questions on, the control side of things. And, we don't want to overpromise things to you, and we don't want you to overpromise things to your customers. So we want to make sure we've got the correct control strategy for this unit for you, and the simplest way possible for you to control it. You got to be real careful with the HBX, because not all the HBX will take, a Wi-Fi thermostat, or maybe a Honeywell thermostat or an Emerson or something like that. A lot of the HBX controls, you must use the HBX thermostats. Now, they do have some very nice thermostats. They have some touchscreen, color, programmable, that are pretty nice. But with the Hydro Connect, you can bring your own thermostats. So if they've got Sensi or Ecobee or Honeywell, whatever they've got, you can use your own stats on the Hydro Connect. HBX zone controls. On the HBX, only one controller can handle one air handler. That's the one thing that's a little bit bad. So if you have more than one air handler, you're going to have two controllers for it, one for each of the air handlers. So if you have, let's say, 2 radiant zones and 3 air handlers, then you'd need 3 HBX controllers to handle that. Again, I'm not going to dive into these wiring diagrams. I want you to see them so that you know that they are in the manual. Normally, this screen that I've got up right now, it's on this next screen, is just the lower portion of it. I didn't want to fit it all onto one screen and be real small. But these are the wiring diagrams for the HBX controls. And so you can definitely look through these in the manual. Basically, let me go back to this screen here. On an HBX, the inputs from your thermostats come in from the top, and the outputs to your zone valves and the unit normally come out the bottom of the controller. Now, you can use zone valves, you can use zone pumps. We're normally going to use zone valves because we've already got the load pump inside the unit. Here's a radiant with air handler just for cooling. Again, you can kind of see the air handler in the upper left corner there. Your thermostat's coming in as your calls, and then an output on the far right that goes to the air handler. Again, O and OC are your cooling demand, and Y1, Y1C would be your high temp heating demand. And these would be all your outputs to your zone valves. You will have to go in and set up your thermostats. It's pretty easy to set them up. The one thing I will say is on this lower right box where it says zone setup, and it's highlighted on priority. One thing that's not, well, it's kind of weird is even if you only have, one fan coil zone and the rest are radiant or whatever, priority will still be 2, and it will never be 1. I'm not really sure why they, 1 is a time priority, and so we don't want to use that. We want to use it as a number 2. So make sure your priority is always set on number 2 for the fan coils. Again, once you get the thermostats and all that, it'll have instructions and it will remind you again to put that on priority 2. But I just like to mention it in the training, so when you go back and watch the video, you can be like, oh, that's right, I need to change that priority. These are just, again, system setups. I'm not going to get into them. The THM 300 is a basic thermostat, and it's not a touch screen or anything, but again, make sure you're letting the thermostat know whether it's a heat only, cool only, or a heat and cool thermostat, and always make sure it's in geo mode. You can, turn your backlight to where it's on all the time. You can go to geo mode, setbacks, there's room offsets. The THM 500 is a real nice thermostat. They look really nice if you're going to use the HPX. Again, here's a radiant heat with air handler heating and cooling call. Again, I'm not going to get too in depth with these controls today. This would be a 550, and again, more THM thermostat setups. Make sure you're set up all the thermostats. They all have to be set up. If you've got the THM 500s, they will communicate with that. Let me go back here with this thermal link. If you've got that module, and they'll link up with your thermostats and the controls together. We can do radiant heat only. Really a simple application here, but you're using a zone 500 control with a THM 100 or a 200. Again, these are outputs. If you have the zone 500, an older version, they have dip switches that have to be set up depending on priorities. Similar to like a like a zone panel, you've got to set up your priorities and thermostats, things like that. It's the same situation on this. The older control made it really hard because you didn't think about setting these dip switches until you've mounted it on the wall, and those dip switches were on the back of the controller. If you look at this control now, the dip switches are on the front because we complained enough about guys having to take it back off the wall that now they put those dip switches on the front so you can see them there. But if you do have an older control and they start talking about dip switches and you're like, what dip switches? Turn the box over and look on the back side. These are just some control modules that have a 16-pin connector that you can push them together, and then they can communicate through the pin connectors. But this would be a radiant heat with an air handler cooling and setting up your dip switches. It talks about priorities over zone 1, over zone 2, and things like that. So just make sure that we know that we've got to set up the priorities and things on the zone controller. Just more wiring. Again, this is why I don't get into it too much on a webinar. If it's an in-person training, we'll dive in a little bit deeper, but on a webinar, I don't like to keep you this long, but if we had to go through all these individually, we'd be here probably till about 4 or 5 o'clock tonight. So you guys would hate me for that. So we won't do that to you. So we'll go ahead. I'm going to show you, here we go. So HD, the heating demand on the WV is your Y1 and Y1C. Your cooling demand is your O1 and O1C. So just remember, and then your Y2 and Y2C will be your high heat demand. So normally that would be like your aquastat setting. So we'll go through here, and I want to flip through these and get over to your, there is the THM 500 for the HBX. Again, real good looking stat, touchscreen, and it's compatible with the Zone 550. So if you're going to go with the HBX and you want Wi-Fi and you want a nice stat, go with this THM 500. They're pretty nice stats. One thing I will say about these thermostats is when you first give power to everything, it'll take a couple minutes for this thermostat to charge up. So when you turn power on, if it's blank, don't freak out. Just give it a 2, 3, 5 minutes or so, and then it'll come on. And when you power it down, it'll stay lit up for a couple minutes, and it'll use up that power in that capacitor that's in the thermostat, and then it'll go off. So it'll take a few minutes to come on, take a few minutes to go off after removal or added to power. Again, we have some alternate controls. I'm not going to get into it, but Hydro Connect zone controls are what I would recommend. Now, again, you can do whatever you want, but as far as tech support goes, right now we support the HBX and the Hydro Connect. If you use Techmar, EWC, or something like that, we'll do our best to give you a hand, but it's something outside of our realm, and so it may be a little bit more difficult to troubleshoot. This is the Hydro Connect control. We're using a Taco zone board, and you can see we've got it set up for you here, where it's the relays are already in there. The zone board, you would hook in your zone valves, and so these would be outputs. These are all inputs from your zones for the calls, and then the Taco would output to the different zones here. You can see we've got over towards the right, we've got the fan coil and the heat pump connections. And if you have more than one fan coil, then we've got an expansion module as well that we can add to it, so you can take care of your other air handlers as well. You can see you got like zone 1, zone 2, zone 3. Those are all basically the thermostat calls from those different zones. Here's that Taco zone board. So that's where your zone valves would be powered in and give the or open up those zones. So again, it comes on this nice little neat board here, easy to mount on the wall, and very simple for just about anybody to be able to wire that in. There's a little more of a close-up for the Taco zone panel there. And again, on the bottom portion is where all your zone valves will go. So as you can see, we do have a couple wiring diagrams for that as well. This would be a radiant heat with air handler heating and cooling. This is diagram HC3. So it will walk you right through on how to wire it in and setting everything up. And we have wiring that we've got a 3-wire zone valve with no end switch. We have a Taco 3-wire zone valve, and then we have a 4-wire zone valve that's power open, self-closing. We're showing different wiring because you may have different zone valves. So we wanted to make sure we tried to cover the main valves for you. And but this is a pretty good layout, a lot easier to wire in, and really a lot cleaner look when you're all finished up. And on an HBX, you're going to have thermostat wires running everywhere, and a lot of times I know people have been to a job site and looked at some wiring with relays and thermostats and things that there's no real wiring diagram for, and it's really hard to troubleshoot because you just find yourself having to trace wires all day long. So this is real nice. It's real clean, good look, simple to put in. So this just just what I'd recommend. Now, we can do ducted zoning. So if you have an air handler and you need, 5 tons of cooling, but you need it for, different areas of the home, we can do ducted zoning as well. And this right here is an example of that. So if you've got, a zone control that you want to be able to use, this is the way to go. This HydroConnect HC4 diagram is the way we would recommend. Here we also have a radiant heat with an A coil on top of a gas furnace and how it would be wired in. So we do offer the dual fuel heating option as well. And then we would use your furnace as the blower for cooling. And this will be a radiant only wiring diagram, how to wire the TACOs or whatever type of zone valve you have. So a lot more simpler, that sounded weird, a lot simpler than the HPX, I'm not gonna lie. Moving on to your hot water set points. The tank will come with an aquastat, a digital aquastat, and it basically provides the dry contact for the WV domestic hot water call. Basically, the hot water set point, sometimes these aquastats can be off by quite a few degrees. So I'm not super concerned of where you've got your set point at, but we want to make sure the aquastat satisfies when the leaving load temperature does not exceed 135 degrees. So basically what you're going to do is you're going to monitor the tank temperature on the aquastat and the unit leaving load temperature on the HMI. Tune the aquastat while the unit is running. If the compressor shuts off, but the buffer tank is still calling, then we've gone too far. So we try to recommend that your band gap is at somewhat of a minimum, but I wouldn't set it lower than about 5 degrees. That way, if we set it the differential at 1, then it's going to short cycle quite a bit. It's going to basically on a differential, it will run the unit. It'll take that temperature. Here it's 5 degrees. It takes that temperature and divides it in half. If your set point's at 120, it's going to run the hot water until it gets to about 122.5 or 123. And then it's going to shut off, and it's not going to come back on until the temperature of that aquastat gets to about 117.5. It gives us a little bit more runtime, and we don't short cycle quite as much. So we want to keep it, I would say, probably about 5 degrees, 5 to 7 degrees is where I normally see that set. The set point on the aquastat really depends on what you want to set it at. I normally see it somewhere around 120, 125. But you can lower it and you can go up to somewhere around 135, but we don't want that leaving load temperature to exceed 135. So make sure we're always double checking the unit running and the actual aquastat setting. Outdoor reset. So with the coefficient of performance, or the COP of a heat pump, it goes up as the load water temperature goes down. So outdoor reset makes a lot more sense and is a recommended control strategy. It's really easy to set up on the unit. I mean, we're giving you the sensor, and all you have to do is choose your heating curve. The outdoor reset's going to vary the design load based on outdoor temperature. So the colder the outdoor temperature, the warmer the load temperature. When it's milder outside, there's no, let's say it's 50 degrees and you still need a little bit of heat. We can heat that area with, let's say, 90-degree water rather than 130-degree water. So it makes the unit run at a lot lower RPM to be able to maintain that temperature. And the compressor doesn't have to work as hard, which lowers amp draw. which makes the COP increase on the unit, or the efficiency of the unit go up. Again, it comes with the outdoor thermistor, and it will accommodate a static temperature set point if the sensor has failed or you can't get the sensor installed yet or something like that. We do have a way to go in there and run it at a set temperature. Follow the manufacturer's instructions for placement and mounting. So just make sure you don't position the sensor in direct sun exposure, because it'll heat it up and then it'll give a wrong temperature. It's recommended that you place it on the north side of the home, maybe underneath the eaves or something, to where it's out of the direct sunlight. Make sure we're always real careful with the flooring recommendation of the manufacturer. You know, you've got some expensive hardwood floor or something. We want to make sure that we're setting up max temps so we don't overheat a floor as well. And we can set that up in the controller itself. And also on, if you have HBX, we can set it up on the HBX thermostats as well. This is the heating curves. When we very first came out with this unit, we only had 1 through 8, but we found that it was better if we had more. Now, it comes from the factory at default curve number 3. And just depending on where you're located, you may have to adjust it. I would say you're probably going to be somewhere in the neighborhood of 3 to 7, but that's just really going to depend on where you're at and you know, what kind of temperatures you're looking at. But again, it does come from at 3 from the factory, which 3 would probably work pretty well for here in Illinois. Maybe a 3 or a 4 here in Illinois, but you get up in Minnesota or Canada or, you know, some of the colder climates, you may be up near the 7, 8 mark. Obviously, as the temperature difference gets greater, then your COP goes down. So that's why we use this outdoor reset, because we can improve our COP so much, you know, looking at our source temp versus our load temperature. Now, obviously, you know, we're not going to heat the home when it's 0 outside with 75-degree water. It's not going to happen. We've got to have the hotter water temperature. But as the temperature outside gets milder, then we can use the lower water temperatures and really increase the COP of the unit itself. We've always also got to take into consideration, you know, our in-floor tube spacings, our flow rates, insulation, things like that. So we get into the WV startup wizard. Again, when you very first start up the unit, it's going to take you into the startup wizard. Now, if you ever go through the startup wizard and you're done running the unit and maybe a couple of weeks later you need to do something and you need to rerun it, you can always rerun the setup wizard or the startup wizard. There's a little button, you can press it and it'll take you right back through it. So let's say you don't have the domestic hot water hooked up yet and you're running the unit, and then you go back and put the domestic water in and you need to reflush, you can go back into this startup wizard and you can add power to that 3-way valve so you can flush out the hot water circuit. Basically, it keeps the pumps, the compressor off until setup is complete, and it will guide you through flushing the load side, and it also will ensure that you get your minimum pump speed set properly. So this is what will come on the screen when you very first give power to the unit. And this is the screen. After you press next, from this screen here, you have a little arrow, you press the button underneath that arrow, and it'll take you to this screen. Now, it'll come from the factory in the house, and you'll need to switch it over to the hot water circuit. So you can go ahead and flush that hot water circuit. Again, it won't take real long to flush that hot water circuit, but we need to make sure we do, or we're going to just dump air right back into the circuit. after you flush both sides, it's going to ask you, or it's going to say, hey, I'm letting you know that this is the last chance before the pumps turn on. So make sure you've got your flushing done. I'm just trying to warn you that in the next screen, we're going to start up the pumps. So here again is the first run setup, and you can navigate up and down and then go in. Like right now, you've got the load pump, 25%. If you want to change that, make sure it's highlighted and push that set button, and it'll flash, and you'll be able to change that to whatever percentage you want. I can almost guarantee you it's not going to be any lower than 25%, and it'll probably be higher in between the 45 and 60% mark. I would probably just start it at 60% and see what the flow is. Make sure that your estimated flow has at least 5 GPM. I would recommend maybe shooting for 5.5 GPM, and make sure that the flow switch says yes. And then open up a zone, your small zone, and see what kind of flow you got. If you don't have enough flow, then you need to raise up your pump minimum or adjust your minimum or your bypass valve if you've got a small zone. But then go ahead and make sure that you're checking with all the zones open and see what kind of flow you've got as well. Make sure, again, that whatever that minimum is, that we always see that 5 GPM and flow switch yes. Next, it'll ask for your heating max set point. So it sets the upper limit of the load out max water temperature. And max heat will supersede anything the heat curve tells you. So if you're setting it up for a max heat for your floor at, let's say, 100 degrees, and your heat curve tells you that at this outdoor temperature, I should have 110 degree water, it's going to look at that heat max and say, I'm not allowed to go over 100 degrees. So I'm not going to go over 100 degrees. Now, this is just when it sees that call for your radiant floors. Once it sees the temperature for like a air handler call or your aquastat, then it's going to follow that heat. But as far as the radiant goes, it's going to look at your the curve and your heat max. Again, we discussed the curves. It comes at curve 3, and you have to adjust it accordingly. After that, the setup is complete. Again, you can always run it later, again, if needed. There's a setup wizard button, and just press it, and you can run right through it again. So sequence of operations. After you've got it all set up, you know you're ready to fire it up and ready to run it. Once it sees a call, the pump is going to start. The source and the load pumps are going to run for 1 minute. So you should start to see them ramp up, and you can watch the screen, and it'll tell you what kind of flow you're moving and what percentage. Now your electronic expansion valve is going to open, and it's going to wait for pressure to equalize. Now, if you look at the screen, it'll say like status or call, and your call, and this right here, if you looked at it, it would say equalize. Now, don't let that fool you and say, well, I should have a call. As it's done equalizing, then it'll go into startup and so forth. So the screen will change as you watch it in real time. So after the EXV is open and the pressures are equalized, then the compressor is going to go ahead and start. The expansion valve is going to be at about 40%. And you'll see the compressor RPMs about 1,650 for about a minute. After that, it's starting to sense things, look at temperatures, looking at flow, and it's going to, the compressor is going to modulate to try to reach the load out target temperature. So you may start to hear that compressor start to ramp up. Then the EXV is going to modulate, and it's always trying to maintain 10 degrees of superheat. And then the pumps are going to modulate the load in the source to try to maintain 5 degrees, while also obeying the minimum pump speed. So if you get down to your minimum pump speed and your delta T is not maintained, what will happen is your compressor will shut off, your pumps will still run. Then when that delta T comes back within range, it'll start your compressor back up. We don't run into that too much unless you've got a small zone and it's dumping through the bypass. That's when we kind of run into the overshoot situation. When the unit shuts down, the compressor ramps down to 0, and then the pumps will ramp down about a minute after that. It will then tell you it's in ASC mode, and it will be in there for 3 minutes. And then if there's no call, it'll say idle on the screen as far as its run status. If the entering source water temperature hits 30 degrees, when the unit's running, the source pump will go to 100%. So it won't worry about trying to maintain. It's more worried about getting some freeze issues, and so it will just run 100%. So the compressor, it's controlled based on outdoor air temperature. It also looks at the target temperature and the temperature curve. And WV also monitors its current load out temperature. Then it's got like a PID algorithm, and it'll throttle that compressor to try to maintain that target temperature. It'll kind of learn as it goes along what it needs to do. So the longer it runs, the smarter it gets, basically. As demand changes, so zones open and close, that compressor will throttle again to maintain that target temperature. And we kind of talked about that overheating condition. If you've got a small zone, about the compressor shutting off, the pump's still running, and then the compressor will come back on after a 3-minute in a short cycle if the temperature has come back within range. It does have a differential overshoot of 3 degrees beyond what that 5-degree temperature difference is. So it'll give it a little bit of wiggle room so it just doesn't sit there in short cycle all the time. But no, if the compressor does shut down and the pumps are still running, it could have just overshot, and it's not really a huge issue. It'll come back on when it gets back within its target temp. If you're switching from heating or cooling or to hot water, the compressor, the unit doesn't ever really shut down and go into ASC. The compressor is going to ramp down to minimum speed, and then the reversing valve or the three-way valve, depending on what you're doing, they're going to be energized or de-energized, and then the compressor is going to ramp back up the proper speed based on the parameters. So unlike some of our other products, the combo unit, the WT, we're not losing 5 minutes each time we switch modes, which is very, very nice. Again, all it does is ramp the compressor down, switch things over, ramp it back up. HMI is going to provide details about the system operation, and you have buttons across the bottom where you can go to the separate submenus, and you're going to have information displayed regarding your sensors, your pumps, things like that. And you can also adjust some of these settings from the user and the service menus. So normally when you walk up to the WV, and this is the screen that you will see on it. Here it's in normal mode. It's in start mode. So your compressor will have little bars on it when it is running, and it'll tell you what the RPM that it is running at underneath it. So in here in this picture, the compressor is not running. The load and source pump volutes, these will have little black bars that kind of spin, and it'll tell you the percentage of the pumps. Those little squiggly lines next to the load and source pumps, those are your electric immersion heaters, so stage 1 and stage 2. If either of those are on, the little squiggly lines will be filled with black bars. So you'll know that stage 1 or stage 2 of your electric heat is on. If you ever have an alarm, that alarm button will be flashing and you'll have a little orange light up here in the corner. I think we'll probably see that here in another picture here. So main menu, again, it's going to tell you the mode of operation, and it'll say normal, test, manual, or emergency mode. Your call, and that would be your current call from your external controls, and it could be heat, cool, or HW, which is hot water. The current status in the sequence of operations. So we have startup, equalize, run, shut down, AST, which is NI short cycle, idle, and we also have lockout. If it's in lockout, it'll say lockout, kind of flash for you. Again, this is the compressor. If you go to the compressor menu, you can press compressor and it'll take you in and tell you a little bit more about it. But on the main menu, again, it will tell you the commanded speed, and animation will be shown with bars running up and down this compressor, letting you know that it's running. The pumps, again, commanded speed and some animation. And then the 2 stages of your electric heat, a little blown up version of those little squiggly lines, those are your heaters. If you press the button underneath where it says comp, it will take you to the compressor menu. Here it will give your compressor feedback from the drive, the allowable RPM range, and the RPM that it's running in. It'll give you your current load supply temperature, the target supply temperature based on outdoor reset. And here it will also show you, we talked a little bit about that case inlet fan, and it will tell you what the inverter temperature is, and that will also move if the fan is on. So it'll tell you what the temperature of the EV2 is, and then if your inverters or your fan is running. If you press the pump button, it'll take you into the pump menu. And here it will tell you if you've got flow switch status, what your entering and leaving water temperatures are, and what the pump speed is. Stats menu, if you press the stats button, it'll show you what your suction and discharge pressure are, your suction temperature, your discharge temperature. It'll tell you superheat, it'll tell you subcooling, and your heat of extraction and heat of rejection. Now, when it shows you heat of extraction and rejection, it will assume that you're using 15% methanol, and I do not have a way to change that. That's just set into it. So a hand calculation might be a little bit different than what you find on the screen. And that's probably why maybe there's a different, they're using exactly 15% methanol, and in a hand calculation, we would normally use the 485. So if you ever have a problem with the unit and you're looking at this screen, it's a great diagnostic tool, but I would always revert back to normal diagnostic tools such as pressure drop, temperature difference, and your refrigerant pressure gauges for confirming what the screen is telling you. Because it's always possible that there's something wrong with the reading of the sensors and thermistors. So always double check with your standard tools. But it is nice to be able to look at it and see what might be going on before you really throw stuff on there. System menu. When you go into the system menu, you could actually change the mode and the call. So mode would be normal, emergency, things like that. It'll show you your current valve position on your diverting and your reversing valve. Here it'll show you your outdoor temperature and again your load and source refrigerant temperatures, coil temperatures, sorry. Menu settings, there's 4 sub-menus. You have indoor climate, hot water, pumps, and system. So if you go to menu, then you can press 1, 2, 3, or 4 and get into these different setups and change things around and run things. So on the, again, you've got the buttons across the bottom to change menus. So you can look at some sensors, your pumps, and settings adjusted from each sub-menu. Indoor climate, you can change it. There's normal mode for the electric heat, which is how it comes from the factory, which is a 20-minute auxiliary delay on the auxiliary heat. Standard mode would be no electric auxiliary, and economy would be a 40-minute auxiliary delay. Then you have your priority, whether you want that to be a heat priority or a cool priority, it's totally up to you. So if you have 2 different calls coming in at the same time, which one do you want to take care of first? You can go and set your own electric heat delay in minutes. If you don't like the 20, 40, or no, you can change it to 5, 10, whatever you want to really change it to. Here you can also set your cooling set point. 45 is default from the factory, 42 is minimum that you can go. You can also set your heat max temp, and you can adjust your heat curve on this chart here as well. Hot water mode, you can do normal, so auxiliary or economy. You can set your hot water priority, whether it's hot water or heating and cooling. Personally, I would choose hot water priority. So when I want to take a shower or something, I can have hot water. Make sure you set your hot water set point. 130 degree leaving is default, and 135 is max. And then you have your hot water delay, so you can change your auxiliary wait time on that as well. Pumps. Here you can go in if you're having problems with the pump or your flow or something like that. You just want to check things. You can go in here and put it in continuous mode, and put on the control mode, put it in manual mode. Then you can go in, once you put it in manual mode, it'll run your pumps to whatever your minimum max speed is, and you can kind of play around with it and see if you're getting the flow that you need. This allows you to go in there and set it up and run them without having to run the compressor and all that. If you're having a pump problem or something, you can go in here and change things up or play around with it a little bit without affecting anything else. System, here is your operating mode. If you want to go in and test the unit or put it in manual mode or emergency, maybe the compressor has failed and they need to use the electric heat and you don't want it to run through the ASC or the auxiliary wait time, you can go in here and put the electric heat on only. And you can also turn the unit off or put it in normal mode. Here you can change temperatures from Fahrenheit to Celsius. So if you're from out of the country and you use Celsius, feel free to change that. Obviously, it comes from the factory in the Fahrenheit mode, but you're more than welcome to use the Celsius if that's what you want to do. You can change the pressure units from PSI to bar. I've never used bar, but you're more than welcome to. And then you can also enter the setup wizard again here. Basically, you can skip it, or you can go down and hold the wizard button down there in the lower left where it says WZRD. You can hold that down and it'll return you to the setup wizard. So if you ever need to go back into it, it's real easy. Also, if for some reason you call tech support and we ask for the configuration version, you'll need to go into the system menu and you can see it says config version 1.00A01. Doesn't really mean a whole lot to you, but it may mean something to us. And we've had a few software updates. So if you're having an issue, it could be due to a software update. We try to keep them updated, but that's one thing we'll definitely ask when we're troubleshooting is what software version you have. A control, it's used for manually testing the unit. So if you have it in manual mode, you can go into the control section and you can turn the compressor on, and you can put it at 1650 RPM or 4500 RPM. I think you might be able to put it at 6000 RPM as well. I'm not real positive about that. But when you're trying to diagnose, it's really hard to diagnose when the RPMs are adjusting and your pumps are moving all around. It's a lot easier when you can set them at a fixed speed and run the unit that way and then diagnose. So this is what the control section is really for. You can set the compressor, I don't know, probably 4500 RPM, set your pump speeds and your diverting valve, reversing valve positions, and then dig into doing some diagnostics. You can also go ahead and turn your immersion heaters on in this mode as well. But this is a really good screen to go into when we do have to diagnose, when we think that there's something wrong inside the box, inside the WV unit itself. Like I said, it's just really hard to diagnose when your RPMs on your pumps are everywhere, and so is your compressor RPM. So we do have a superheat menu where you can change the superheat, but I would not recommend it. But it is available, and if you do think you need to change it, give us a call. I'll have you talk to one of the engineers, and we'll decide whether we want to do that or not. I haven't seen anybody that's had to change that yet. So again, the HMI, the measurements are for reference only. And if there is a problem, always verify it with the tools that you normally would on a standard geothermal unit. Faults and alarms. So you will have a flashing red light up in the upper right portion of the screen. The alarm in the lower right on the screen will flash. There will be an audible alarm that will beep. And on the status, it will say lockout. Now, if you need to clear the faults, you're going to have to power the unit down. I need to check in. I have heard that you can press the alarm button down there 4 times and it'll silence it as well. Not positive on that. But if there is an alarm, you want to press that alarm button at least once, and you can get to the alarm menu and it'll tell you what that alarm is. Once you press that alarm button, it'll take you to 3 separate alarm menus. So we have iPro, which is the system faults and alarms. So if you get a low pressure lockout or a flow lockout, something like that, those are going to be in the iPro. So if you hit that iPro, it's going to bring up CO1 through C12. Now there's more, there's like 20. So you can see the arrow up in the upper right corner of the screen. There's more screens that you can go through. So when you come up to the alarms, it'll immediately take you to the CO1. Well, CO1 is a low pressure alarm, but that's not the alarm that's active. The alarm that's active will have a notation next to the CO1 or CO2 that'll tell you. Now, it'll also tell you what the alarm is. Like CO1, you can see it says low pressure, but that's not the fault. So we're going to have to scroll through and find the one that's faulted. So we're on CO1, but we need to scroll down to C11 because that's the one that's got the fault. Once we scroll over to the C11, it will tell us load loss of flow, switch. Now, we have a couple different flow indicators. We have flow switch, flow sensor, and there's one more, and I think it's a sensor fault. So there could be 3 different flow faults, all related to the same thing. So you just have to find out which one it is, scroll down to it, and then it'll tell you what the fault actually is. There could be multiple pages, so you will have to scroll through and to let you know which fault that it is. If you're on the alarms menu and you press the iPro button twice or once, you pressed it once to get to this screen and then press it again, it'll show the alarm history. It'll tell you how many hours ago that fault happened and what that fault was. So here you can see 3 minutes ago, we had source loss of flow feedback. You know, it went 3 minutes, 7 minutes, 10 minutes, 12 minutes, 14 minutes, and you may have to scroll through and it'll tell you obviously how many minutes it's been since it happened. It will keep the 10 most recent faults on the system itself indefinitely. So again, when you get a flow fault, it's very possible to have quite a few faults because you got flow feedback, flow sensor, and flow switch. And normally, if you are really having a flow problem, you're going to have the flow switch, and you're probably going to have at least the flow feedback, loss of flow. Both of those are probably going to show up. And that would pretty much let you know that you almost positively have a flow issue of some sort. If you just get a flow switch or just a flow feedback, it could be something involved with just that sensor or just that thermistor that had the actual issue. So system faults and alarms, we have a chart that we have in the manual that will tell you what all these faults mean. I'm not going to go into all these faults today. They're in the manual for you. There's even tips on what to look for. So, you know, I don't remember what all these faults are. You know, there's like 40 or 60 different faults that we could have. And so I don't expect you to remember them because I'm not going to remember them. So just know that they are in the manual and they are in this training. All the C faults are more of system faults. We have D faults like D01, which would be drive faults. And then there's a couple other faults as well having to do with different controllers. So the majority of the time, you're going to see the C faults that are going to be the system faults that are going to be most prevalent. So, you know, you got low pressure, high pressure switch, high pressure transducer, high entering and leaving source and load water temperatures. You got all these different thermistors and sensors that could fault out. So we got source loss of flow, load loss of flow, high discharge gas. So there's quite a few on here that could fault out. Low superheat, system equalization issue, quite a few things. So those are all the faults. Troubleshooting, obviously you got to understand the sequence of operation. Again, if you don't know whether it's a control issue or a unit issue, the easiest way to figure out if it's a control issue is to remove the controls from the circuit and jumper the unit. Just jumper Y1 to Y1C and see what happens. Or jumper out O to O1C or the O to OC1 and see what happens. Does the cooling come on? Does it start to run? If it does, then we know, hey, it's not inside the box, it's outside on the control circuit. Or, you know, vice versa. Understand how that system works, how it's supposed to operate, how it takes time to ramp up and ramp down, and how it, you know, it's really trying to go. Heat of extraction, heat of rejection still apply. So when we're doing heat of extraction and rejection, we always start with our water flow. So that's where we're going to start too. You know, make sure we've got water flow and then move on from there. So always look at your heat of extraction, rejection on a fixed point. Don't try to do it with the variable speed running. Go to the manual mode, set it in a manual setting, and then we'll be able to tell a lot easier what our issue really is. And again, you can use the onboard controls for diagnostics and readings, but then always revert back to your hand tools if need be. So there's obviously three main criteria for a ground source heat pump to operate properly. So we've got to make sure we got water flow. So properly sized energy source and energy dump. Make sure we've got proper power to the unit. And the heat pump and the refrigerant components obviously need to be functional. You know, if the compressor's not running or won't run, obviously it's not going to work properly. So we have to get that fixed before we can even figure out if the unit's working properly or not. But always start out on water flow. Water flow, water flow, water flow. You know, with an air source heat pump, you can see if you've got airflow. You can feel if you've got airflow. Water flow, it's inside of a pipe. Sometimes you can hear it, which you probably shouldn't, but so it's hard to know if you've got water flow or not. So that's why we've got ways to check, and we always want to look for that water flow first. It's half the battle. Again, make sure we're always sizing properly on the loop fields, your pump sizes, your flow centers working properly. If you have a problem with the variable speed pump on the flow center, it's not communicating with the system or something, on those variable speeds, if you disconnect the low voltage Molex connector and the pump does not run 100%, then there's a problem with the pump itself. If it does run, then you know it's something more in the control inside the unit. And that's on any variable speed pump, whether it's a Magna that you've got on a standard air source or the Magna that's on this WV. You unplug the Molex, it confuses the motor and runs it at 100%. I kind of wish they would do that with the ECM blower motors too. So you could at least have airflow when the module failed, because we all know that's just the module that fails, it's never the pump or the motor itself. On a pump, it could be the actual pump because you could have maybe bad water or air in the system or something like that. But easy way to tell if it's a pump or the control is to unhook the Molex connector. And if it runs 100%, then you know it's a connection or a control issue. Make sure we're always flushing load and source. And if you've got an air handler on the load, try to isolate it and just flush it by itself. Otherwise, it's going to take you a little while to flush it. It's hard to get the air out of those, out of that air coil for some reason. We just found that out from experience, basically. Make sure you got the proper amount of antifreeze. If you're doing chilled water on the cooling side, make sure you're putting it there. And make sure you've got enough antifreeze, but not too much. Propylene glycol has issues with damaging pumps if we've got too much because it's real thick. And then if we don't have enough, things are going to freeze up prematurely. Biological growth is an issue. With methanol and ethanol, too little, we just don't have enough freeze protection, and too much, and it could be flammable. So make sure we've got antifreeze in the system in the correct amount. Make sure you're always verifying pump speed and that you've got your bypass valve set up properly. If you've got a flow problem, that's what we'll always start at first, is checking those pumps, putting them in manual mode and running them and seeing what kind of flow you got. Again, load water flow is not real different. Make sure you're sizing the zones for proper GPM, proper piping for low turbulence. Be careful with the zoning. Make sure you're setting up that bypass valve properly and your minimum pump speeds properly. Power supply, obviously we've got to have proper transformer size. I'm not talking the transformer in the unit, I'm talking at the home. Make sure they've got their service size, because we've got 2 50-amp circuits just for the Geo unit. So if they had a gas furnace in their home with no cooling, they may need to upgrade their panel size to be able to accommodate the electric heat and the Geo unit. Again, you don't have to have electric heat in the unit. So if they don't want to upgrade their panel size, but they got enough just for the Geo, you could still install it with no backup heat. Or if they had a boiler for backup, you could probably do that as well. But secondary wire size, make sure you're installing proper wire size and heat pump wire size from the panel to the unit itself. Make sure all your controls are hooked up, wired in properly. Again, easy way to find out if it's a control issue is just remove that green terminal strip and jumper the unit. I'm not going to get really into the troubleshooting today. If you've got some troubleshooting problems, all this information is in the manual. I'm hoping you won't have to troubleshoot it. But you know, there will be a time when it will have to be diagnosed, but I would always start with checking the power supply to the unit, check everything outside the unit before you go digging inside. Just kind of speed things up. So one thing that you can do and look at real quickly is the HMI and also controller lights. If you don't have lights on a lot of things and your HMI is blank, it could be a power issue. So again, not going to really get into the troubleshooting a whole lot today. All this is in the manual to try to help you, but I guarantee you'll probably call us when we are troubleshooting it. So just know that like flow faults, they can be triggered by pump feedback of the flow meter and the flow switches. So there's 3 different things that it could be checking on. So, you know, you'll check, make sure your pump's got power right off the bat, and then check your control signals, your minimum pump speeds, things like that. High pressure and low pressure, it's pretty obvious. Water flow could be an issue. Obviously, switches or boards can be the problem. I don't really see a blocked or seized expansion valve. Again, I've seen one head fail on the EXV, but that's it. So that's a good sign that we're not having issues with expansion valves. But low pressure, again, refrigerant issues, check water flows, things like that. It could have EXV issues, could have low pressure transducer issues. It will normally tell you what that fault came from, whether it came from a pressure switch or a pressure transducer. And we have ways to check those pressure transducers that you know, we can find out if they're good or bad. We can ohm things out, that kind of thing. High pressure lockouts, depending on what mode. Again, too much antifreeze, not enough flow, EXV issues, you know, all that kind of stuff. So again, I'm not going to get real in depth on all these lockouts. Again, we put a lot in our manual now to try to help out as much as possible. And I think we've got an update to the manual here real soon. I just got some more troubleshooting stuff from Kip on Friday that I'm slowly putting into this training as well, and they will be in all the manuals. Again, we have source, freeze, and flow lockouts. Could be flow switches, transducers, feedbacks. Again, look at the alarm menu, and it will tell you where those faults are coming from. Here's the control for the expansion valve. Again, there should be lights flashing, the TX, RX. You can kind of see over there to the right, open and close. Those should be flashing. So make sure that they have lights. If there's no lights there, check that little green connection and check your connections on the wiring. If it still persists, then give us a call and we'll dig into it a little bit deeper. The variable speed control for the compressor has red and yellow lights that will indicate a problem based on pulse count. It's highly unlikely, but if you do have some issues and you're looking at that, you do have a pulse count, count that pulse count, give me a call. We'll get you in contact with the engineer and we'll figure out what the problem is. The fortunate thing is I haven't seen too many issues with this EV drive. The only problem I have seen, if ever you have a lot of faults and you're cycling power on the unit quite a bit, I have seen the HMI, the human module interface screen fail to pop up and it just remains blank. If you do see that in the field, there's not really a whole lot you can do. You'll have to get a new HMI for the unit. But I think that they've addressed that issue for the most part and shouldn't see too many of those any longer. Future versions on the WV, sooner or later we will have a colored HMI touchscreen, and we'll be able to connect to the cloud. And then that way we can get telemetric data reported to the dealer and to technical support at Enertech. So what our end goal would be to have a board in tech support, and we come in the morning or throughout the day, look at that board, and we say, oh, home number 2398 has a flow feedback fault. It will let the dealer know, and it'll let us know, and we can either contact the dealer, let them know that they do have a fault, or the dealer can contact the homeowner and say, hey, your unit's faulted out. Did you know that? And would you like us to come take a look at it? And we can also look at that data and kind of get an idea of what may have caused it, and maybe not even have to go to the job site, maybe able to direct the homeowner to reset the unit and get it to operate. But we're not quite there yet. There's some licenses and things that we've got to get, but that's where really the future of our industry in general is going to go. I mean, you got all these Wi-Fi and communicating thermostats and all this data we can collect. We can actually go to the unit itself and plug into the USB and dump a bunch of information in the computer, and then pull those text files out and see where the problem may have occurred. We can tell if you ran it in cooling 6 months ago, so we can kind of look at that and figure out where our problems may align. So we still have a way to get that data, but we'd like to be able to report that through a cloud and pull it off so we don't have to actually go to the job site. But if you get to the job site and you want to download that information, let us know and we'll explain how to do it. And then we'll have to have you send those files over to us, and we can convert those over to a file that we can read, and then we'll share that information with you. So that's where we're at for right now. Moving forward, you guys got any questions, comments, or concerns, or changes that you would like to see made on it? Feel free to let us know, and we'll definitely we'll definitely consider your recommendations and kind of go from there. But I'll open it up for any questions, but if there's no questions or you think of some later, here's our contact information. You can email me at the training website or email, or you can email me directly, and I can work with you directly. I can get you in touch with our tech support if that's what you need, or if you need some design help, we'll definitely help you there too. So again, thanks for everything today, and holding on for a long period of time. And I do have a training tomorrow if you'd like to sign up. It's only an hour long, so not quite as long, but it's basically just how to do heat of extraction, heat of rejection on any geothermal unit. So check it out and sign up. It's another free webinar. Again, it's only an hour long. So thanks again. Any questions? I'll be around for a few minutes. If not, have a great day, and I appreciate your time.